Most recording engineers are trained from day one to avoid distortion at all costs. They're taught about proper signal levels and gain staging, and to keep a watchful eye on the meters at all times, to make sure things don't go into the red. But then, after they get past the basics, they discover that there's more to the picture, and that distortion can be friend as well as foe. And as they delve further into the history and practice of the recording arts, they come to realize just how much distortion, both obvious overdrive and subtle saturation, actually contributes to the sound of most recordings. Of course, guitarists have always relied on driving their amps hard to bring some edgy character and sweet sustain to the sound of the electric guitar, and they usually come to be connoisseurs of distortion, the different qualities available from the various circuits that can be overdriven to produce that coveted crunch. But electric instruments like guitar are not the only beneficiaries of a little overdrive, and guitar amps are not the only devices that can produce distortion that adds something positive. The more subtle saturation of standard recording and mixing gear can often add a bit of magic, that famous analog warmth everyone seems to crave. Still, too much of a good thing, or a good thing applied in the wrong way, can produce less than ideal results. Deliberately utilizing distortion as a tool in recording and mixing can be a matter of inches. Do it right, and it can add anything from a pleasantly subtle extra presence to a flat-out blast of grinding goodness that can add some throaty roar to an otherwise bland tone. But do it wrong, and you can end up with negative results, a loss of clarity and detail, and a mix that quickly induces listening fatigue. So, it's not surprising that, as engineers and mixers are walking that line between bad distortion and good distortion, there'll likely be a few mistakes made along the way. Specific choices or habits they may fall into that might not be the most effective ways to use this dual-edged tool. This series of courses, 10 Mistakes or 10 Don'ts of various production activities, focuses on some of those things, common and sometimes less common uses and applications that it would probably be best to avoid. This course, of course, covers 10 things to watch out for when utilizing distortion and saturation. It presents a series of suggested don'ts, mistakes, or just less effective practices, along with suggestions for alternative approaches that might enhance the use of the effect. The course assumes a basic familiarity with the ins and outs of distortion, but just to be thorough, I'll do a very brief review of the basics before jumping into the 10 don'ts themselves. Distortion in audio circuits is the result of a change in the shape of the wave that usually comes from pushing a particular circuit component, like a tube for example, beyond its limit of linear operation. When signal level exceeds the ability of a device to respond to the level swings of the waveform, the tops and bottoms of the wave are clipped. They flatten out to some degree. This kind of change in the wave shape alters the harmonic content of the wave. Specifically, it creates new harmonics, adding to or enhancing the ones that are already present. This is the most classic form of distortion, harmonic distortion, as produced deliberately by overdriven guitar amps in large quantities, but also to a smaller, more subliminal degree by many other standard analog recording and mixing devices. Since harmonic content determines the timbre or tone of the sound, the clipped, distorted wave takes on a different tonality. As I said, this can range from subtle extra warmth and presence to full-out crunch and grind. There are many types of circuit components that can produce distortion, each with their own distinctive distortion character. In either large or small quantities, the deliberate introduction of distortion with a suitable quality can enhance various elements of a recording or mix. When analog equipment was the only game in town, everyone kind of took this for granted until digital took over. An all-digital signal path, if used properly, doesn't produce the kind of small, subtle distortion and saturation that gave analog audio its character, and when recordists realized why the new medium somehow sounded more bland and lacking in warmth, they set about to simulate the inherent desirable qualities of the less pristine analog gear that was responsible for so many rich-sounding recordings. At first, digital modeling of analog distortion and overdrive sounded, well, not so great, but eventually software designers got the hang of it. Nowadays, you can get that analog edge from not only real analog gear, but excellent digital simulations of the pleasing qualities of distortion in both subtle and obvious applications. Even digital distortion, which usually is best avoided for its harsh character, can still be put to creative use, when that really nasty industrial edge may be called for certain musical styles and effects. But always, The key is not only to choose the best type of distortion to enhance a certain sound in a certain situation, but also to apply whatever kind of distortion you choose in just the right way and to just the right degree to avoid turning a positive into a negative. And that's where this course comes in. So, with that brief rundown out of the way, let's start taking a look at some of those things to watch out for when utilizing distortion and saturation to pump up the sound.